So still on the concept of vector dot products, how do we determine the area of a triangle using the concept of vector dot product, isn't it? So you've been told to determine the area of a triangle whose sides are the vectors A is 3i minus 2j plus 4k and B is I minus 5j minus 2k. So the first thing, if this is our triangle, here, then in this triangle, you've been told one of the sides, if this is the angle theta, then one of the sides is vector A and the other side is vector B, isn't it? Are we together? Is that okay?
Yes.
So you see, I'm always putting both the vectors to be originating from this point. So maybe that point I can always take it to be the origin, isn't it? Can always take it to be that. So it doesn't matter that direction aspect, we know all vectors originate from that origin. So here it means for us to get the area of this triangle, you know the area of the triangle is a half AB sine theta, meaning the magnitude of this vector A to be A and the magnitude of this vector B to be B, the length, isn't it? The length. Are we together? So for you to get this area is a half AB times the sine of the angle between them. So we need to get the length of this vector A, which is the magnitude of vector A, isn't it?
Yes.
And we need to get the length of this vector B, which is the magnitude of vector B, and times the angle of the sine of the angle between them. So we cannot get this area if we don't know this angle theta, isn't it? We can only get this angle theta using the vector dot product, isn't it? So from the vector dot product, we know that vector A dot vector B is given by what? The magnitude of vector A times the magnitude of vector B times the cosine of the angle between them, isn't it? So you start, what is your vector A? Vector A you've been given to be 3i minus 2j plus 4k. Then vector B you've been given to be I minus 5j minus 2k. That is what you've been given to be vector B, isn't it? So the first thing we are looking for is A dot B. Vector A dot vector. So vector A dot vector B, it is x times x. I squared is 1, isn't it? So x times x, this is a silent 1. 3 times 1, you get 3. Then it is plus y times y. Negative 2 times negative 5, positive 10, isn't it?
Yes.
Then it is plus z times z. Positive 4 times negative 2, minus e. So at the end, what do you get? 3 plus 10 plus negative 8, you get? You get 5, because this is 13 minus 8, isn't it?
Yes.
You have 5. Then the next thing we look for is the magnitude of vector A, isn't it? And that magnitude of vector A is what? The Pythagorean theorem. That is the square root of x squared plus y squared plus z squared, isn't it? So x of vector A is 3. So it is 3 squared plus y of vector A is negative 2. That is negative 2 squared plus z of vector A is positive 4. That is 4 squared. So what do you get to be the magnitude of vector A? Using the Pythagoras theorem? 5.39, isn't it?
Yes.
Then you move, what is the magnitude of vector B? Pythagoras theorem. So x squared, what is x of vector B? 1. That is 1 squared plus y squared, what is y of vector B? Negative 5, isn't it? That is negative 5 squared plus z of vector B is negative 2, isn't it? So plus negative 2 squared. So what do you get to be the magnitude of vector B? 5.48, isn't it? So the next thing is just to substitute, isn't it? Where there is A dot B, you put the value of A dot B, which you found to be, we just substitute. We just substitute A dot B, we found to be 5, isn't it? So that is 5. Then magnitude of A times magnitude of B, 5.39 times 5.48, you found 0.5? 0.54, then times cos theta, isn't it? So for you to get cos theta, you must divide both sides by 29 point. You must divide both sides by 29.54. So what do you remain with to be cos theta? 5 divided by 29.54? 0.5. 169. So what is theta? It is the cos inverse of 0.169, isn't it? Which you found to be 80.25 degrees. So after that, we can now get the area of the triangle, isn't it? The area of the triangle is a half AB sine theta, where we say the A was the magnitude of vector A, isn't it? And we say the B was the length of vector B, which was the magnitude of vector B. Are we together?
Yes.
So what do you get to be the area? It is a half times A, which is the magnitude of vector A, times 5.39 times B, which is the magnitude of vector B, 5.48, then times the sine of the angle between them, sine 80.25 degrees. So what do you get to be the area of that triangle? 14. So 14.56, and you know it is square units, isn't it? 14.56 square units. So that is how to determine the area of a triangle, meaning you can only determine the area of that given triangle using the concept of the vector dot product. Okay?
Yes.
Good.